Hello everybody, my name is Tim Connors. I am the Senior Market Manager for our energy and chemical markets, and I'm going to be talking to you about our FCCU wear products today. Although Blasch has many different markets we serve, we're only going to be talking about the chemical and petrochemical markets for this particular discussion. In particular, we're only going to be focusing on the bottom row of products you see here. As you know, Blasch has many different products within the refinery. Our Prolock ferrules, hex walls, vector walls, and stay block systems are used widely. But today we're only going to be focusing on the abrasion applications that you see on the bottom. In particular, we're going to be focusing on our distributor grid nozzles, critical flow orifice nozzles, Inductor scrubber and venturi linings, flue gas coolers, ferrules, piping and elbows in the catalyst unloading lines, cyclone dust bowls, dip legs, and other cylinder sections, CO boiler division wall, and thermal well sleeves. Several years ago, about a dozen now, Blasch developed an alumina bonded silicon carbide we call Altron. We had been working with a consultant in the industry to address abrasion in these distributor grid nozzles that are often metallic. In general, ceramics do much better from an abrasion standpoint compared to metals, so it was a natural fit that we would offer these components in a ceramic design to address the abrasion that the clients were seeing. Altron was eventually developed, and we saw some exceptional abrasion resistance with this material. Through a test called ASTM C704, it's a direct impingement, 90-degree impingement onto a roughly about a 4.5 inch square plate. We were achieving numbers approaching 1.5. If you're not familiar with the test, anything that is approaching zero is excellent. It's basically a measure of how much material is removed from the surface. So something in the 1.5 range, a little under 2, was an exceptionally abrasive material that worked well for the application. We further analyzed the material to make sure that it was suitable for a cat cracking unit. We measured the thermal shock resistance by cycling it. We measured the acid solubility, the oxidation resistance, and a host of other tests were performed on material. One of the most important features touched on previously was the abrasion resistance. And although we have our own in-house C704 tester, most clients wanted it to be approved and tested by independent labs, such as the ones listed here. In particular, one of them had cycled the material up to about 1500 F and then remeasured the abrasion resistance. And in general, both of them got between 1.5 and little under 2 cc loss. Now, why that's important is compared to the existing or approved refractory material for cat crackers, which happens to be a hex mesh type castable. Those numbers are, as you can see in the upper right, are roughly around 3 to 5, and that's a lab test. Now, in the field where you're installing it and you have to apply moisture and dry it out, cure it out, we suspect that those numbers are actually worse. Where Blasch is Altron, it's fired in a controlled atmosphere, fully dried, fully cured, put in a box and ready to install. We are accurately getting well below 2 cc loss for this material. Here is a short user list of people that have implemented the ceramic Altron grid nozzles. Over the years, there has been many materials that have been tested to replace the metallic nozzles, from nitride bonded silicon carbide to reaction bonded. Altron seems to be falling in the 10 to 20 year lifespan. We haven't really seen much abrasion of the ceramic itself. Often it's the metallic holder or collar that's around the nozzle is where we see the abrasion. In order to facilitate the actual welding of the ceramic nozzle to the lateral pipe, the header, or the plate, you have to incorporate a metallic shroud, if you will, that holds and encases the ceramic. Most of the abrasion is on the inside. And what Blasch does is we mimic the exact orifice size, length, diameter everything that's existing with the steel nozzle. We do not try to change that. But what we do is we match the ID, we develop a ceramic around that ID, if you will, and then we attach a two-part welded and compressed collar around the perimeter. Pictured on the left is an example of a single stage nozzle with the welded two-part collar system that we engineer. And pictured on the right is a typical grid nozzle generator type ceramic drawing. This is typically what we see. These are the types of pictures that we get from clients that are experiencing catalyst losses or nozzles wearing away. Often what happens is one nozzle will start to abrade, and the flow path of the air coming out will cause a unique situation where it starts to impinge upon its neighboring nozzle, the pipe itself, or even the refractory that surrounds it. Once that starts happening, it's almost like a domino effect, and that the nozzle next to it starts to wear away, and that in turn causes the next one to start to wear away. Here is a typical drawing of a distributor grid, and in particular, the picture on the bottom left shows our ceramic grid nozzle assembly welded to a lateral pipe. You can see the S-shaped anchors that are welded on. That is where the hex mesh or the castable protecting the steel would be applied. This is a plate style grid where it's a large plate with a series of holes drilled into it. Over time, these round, precise orifice holes or openings tend to abrade away, and it almost looks like a key slot, which is not ideal. What Blasch does is we develop a very small ceramic insert that fits inside the hole itself, and then to facilitate holding the ceramic, we just have a single steel collar that is welded in place. Another application out there is called the critical flow orifice. Very similarly as the grid nozzles, all we do is we replace the wear surface, the ID or the bore, with a cast ceramic element that gets inserted into the steel pipe. Another application that's prevalent in the industry is what's called an Inductor scrubber nozzle. Basically, it's a large silicon carbide sleeve and tapered cone that sprays a solution over the exhaust gas stream before it goes out the stack. These tend to see some abrasion due to the high velocity of the solution, and we make these quite a bit in silicon carbide. At the bottom of the scrubbing tower, this one particular client was seeing some excessive abrasion at the turn or the bend. So Blasch engineers came up with an interlocking tile arrangement that was welded and mortared in place. Pictured here, you can see the before and after installation of these tiles. These happen to be stud welded in 4 locations and were also back filled with some mortar to hold them in place. And then in the upper sections, the upper and left side of the wall and right side of the wall, a hex mesh castable was installed. But most of the abrasion was seen where the tiles were located. In the venturi section, where the Inductor nozzle does spray the solution onto the side walls, you can experience some abrasion in that area. So Blasch can come up with either a 1 or 2 or 3 part component system that can fit in place. In larger sections, we will employ an interlocking tile arrangement, much like the elbow we did previously. Another application is in the flue gas cooler area. This is a waste heat boiler. Not every plant has this, but it's similar to like a sulfur recovery unit or a conventional waste heat boiler. But in this case, instead of high temperature corrosive gases, what we see here often is abrasion. And instead of making the ferrule and the conventional high alumina material that we do so widely throughout the world, in this case, we use a silicon carbide based material to protect the inlets of the tubes and the welds in the tube sheet. In the spent catalyst unloading lines, Blasch can employ its Ceraline product, which is a smooth bore ceramic line piping system. Basically what we do is we pre-engineer and cast ceramic sleeves that interlock together within a steel pipe, and then we backfill the joint or the area in between the outside of the ceramic and the inside of the steel with a mortar, glue, epoxy, or polyurethane, depending on the application and temperature. Although we can make many sizes and shapes and profiles such as T's, Y's, laterals, elbows, and straights, we do have somewhat of a limitation on the length of the sleeve itself. In this case, it happens to be 7 foot long. So this particular 14-foot long ceramic line pipe section, we made it in 2 pieces and then interlocked it together and assembled it as one unit. Within the Cyclone itself, where the large diameter sections taper down to a smaller cone or sleeve section, there's what's called dip legs and dust bowls. And instead of employing a hex mesh cast spool in those tight areas, Blasch can make a single component ceramic sleeve that can be slid into place. In the second or third stage Cyclone Separator, which tend to be smaller, Blasch, instead of making a liner, can actually make the exact shape in ceramic and then mount it with a steel collar. Pictured on the left is a Cyclone vortexer or spin vane that imparts the rotation on the Cyclone Separator, and that's something that we can make exact replacements in ceramic. Using our know-how and experience we've developed over the years with our hex wall and vector wall systems, Blasch engineers came up with a diffuser wall and a CO boiler, pictured here. For this particular customer, they were experiencing non-uniform flow path, pictured on the bottom left. By implementing this diffuser wall, which is a series of interlocking tongue and groove brick shapes with an engineered hole, Blasch engineers were able to distribute and break up the flow uniformly. In the coker section of the cat cracker, there's often these series of wear sleeves and cyclone linings and various odds and ends. This is sort of the catch-all of where Blasch comes in. If you have any monolithic structures, brick structures, castable gunite, that you are experiencing cracking, abrasion, spalling, and you think an engineered interlocking tile arrangement, sleeve, or nozzle might fit the bill, please contact us. This is something that we can help you with. If you have a thermocouple or thermowell, Blasch can produce a ceramic sleeve that will protect the elements. The last thing I want to touch on is basically a new development that we've been working on for the past few months. We are trying to come up with an interlocking shiplap or tongue and groove tile arrangement to line the entire Cyclone. I want to thank everybody that sat in on this. If you have any questions, by all means, you can get in touch with me, or you can contact us on our website. Thank you.